Imagine the smallest thing you can, a grain of sand, a speck of dust. Now delve deeper into the realm of the invisible, to the very building blocks of matter atoms. These tiny universes hold within them an almost unimaginable power, a force that binds their core and, when unleashed, can reshape the world. Atoms, the fundamental units of everything we see and touch, are composed of even smaller particles. At their heart lies the nucleus, home to protons and neutrons. The dance of these particles, bound by the strong nuclear force, is a delicate balance of energy. It is in this dance, in the splitting and fusing of atoms, that we find the source of the atomic bomb's devastating power. Albert Einstein's famous equation EmC2 revealed an astonishing truth. Mass and energy are interchangeable. The discovery of nuclear fission in the 1930s, the splitting of an atom's nucleus, opened a door to this previously unimaginable power. Scientists realized that by bombarding certain heavy atoms like uranium, they could initiate a chain reaction, releasing unimaginable amounts of energy. The atomic bomb, a weapon of unprecedented destructive power, is the physical manifestation of this scientific understanding. It harnesses the energy released by nuclear fission, unleashing it in a terrifying explosion of heat, light, and radiation. Two main types of atomic bombs exist: fission bombs and fusion bombs. Fission bombs, the type first developed, rely on the principle of nuclear fission. They utilize highly enriched uranium or plutonium, heavy elements capable of sustaining a chain reaction. When a critical mass of these materials is brought together rapidly, a neutron bombardment triggers a cascading fission process. Atoms split, releasing energy and more neutrons, which in turn split more atoms, creating an exponential release of energy in a fraction of a second. Fusion bombs, also known as thermonuclear or hydrogen bombs, are even more powerful. They utilize nuclear fusion, the process that powers the sun, to fuse isotopes of hydrogen into helium, releasing an even greater amount of energy. The result is a weapon with destructive power that dwarfs even the largest fission bombs. The development of the atomic bomb is inextricably linked with one of the darkest chapters in human history, World War II. As the conflict raged, a different kind of battle was being fought in secret laboratories, a race against time to unlock the secrets of the atom. This effort, known as the Manhattan Project, would change the course of the war and forever alter the geopolitical landscape. In 1939, as Europe stood on the brink of war, a group of concerned scientists, including Albert Einstein, penned a letter to President Franklin D. Roosevelt. They warned of the potential for Germany to develop atomic weapons and urged the United States to initiate its own research program. Thus began the Manhattan Project, a top-secret undertaking that brought together some of the brightest minds in physics and engineering. On July 16, 1945, at a remote test site in New Mexico, the world's first atomic bomb was detonated. The Trinity test, as it was known, unleashed a blinding flash and a mushroom cloud that soared miles into the sky. Within weeks, the United States, facing a Japan unwilling to surrender unconditionally, made the fateful decision to use these newly developed weapons. On August 6, 1945, an American B-29 bomber dropped an atomic bomb, nicknamed Little Boy, on the Japanese city of Hiroshima. The atomic bombs dropped on Hiroshima and Nagasaki unleashed a level of destruction never before witnessed. The immediate blast wave leveled buildings for miles, while the intense heat ignited firestorms that raged through the cities. Tens of thousands perished instantly, vaporized in the unimaginable heat, while countless others succumbed to burns, radiation sickness, and cancers in the days, weeks, and years that followed. The long-term effects of radiation exposure continued to plague survivors for decades, leading to an increased incidence of cancers, birth defects, and other health problems. The psychological trauma of the bombings, the loss of loved ones, and the lingering fear of radiation poisoning left an indelible mark on the survivors and the Japanese psyche. The bombings of Hiroshima and Nagasaki marked a turning point in human history. They ushered in the atomic age, an era defined by the constant threat of nuclear annihilation. The world now lived in the shadow of the bomb, aware that the power to destroy civilization itself was within reach. The legacy of the atomic bomb is a complex and challenging one. It is a story of scientific ingenuity intertwined with the horrors of war, a stark reminder of humanity's capacity for both creation and destruction. Yet, amidst the darkness, there is a glimmer of hope. The very power that threatens our existence also holds the potential for progress. The international community, recognizing the existential threat posed by nuclear weapons, has made strides towards disarmament. Treaties like the Nuclear Non-Proliferation Treaty and the Comprehensive Test Ban Treaty aim to prevent the spread of nuclear weapons and limit their testing. While challenges remain, these efforts represent a crucial step towards a safer world. Moreover, the same technology that fuels the destructive power of atomic bombs also holds immense potential for peaceful applications. Nuclear energy, harnessed in a controlled manner, provides a clean and efficient source of power, reducing our reliance on fossil fuels and mitigating climate change. As we grapple with this legacy, we must strive to harness the atom's power for good, to ensure that the horrors of Hiroshima and Nagasaki are never repeated.